Hello, welcome to another video. Um, so I thought I would get into we can get this. How do we get this? So yeah, golly, give me the window. So I thought I would look at kind of implementing SHA-2. So I have in the past golly, what is it? It's GitHub queued input and SHA-1 I've done in the past is like a STB style file. So pretty much all you needed was the .h file. It's like 200 lines for the SHA-1. And this was kind of done because I was doing BitTorrent for reasons I kind of want to also kind of make a SHA-2. So I'll kind of get into that. Now, the licensing of this is it's like patented by the US, like the government, but it's like under a royalty-free license, and you can get it either from golly, where was it? You can get it from their NIST page. Is this it? Like there is just a well, I suppose if I thought about it, it would use the contents, and there'll be external links, and one of these external. So wiki, like this should probably close after I do it. I don't know. Well, it's like a click go through. I don't know. I'm kind of thinking of things through, but yeah, is this the one? Yeah, there's like a big PDF. That's kind of it, but it's like all kind of linked through the archive. Golly, I had found one. Is this something that could be useful? No, this is like, and like, can we get you to be, we get you to be, it's interesting you couldn't get it from there. So is this the one with, yeah, cool, easy. Right, so this is the one. US secure hash algorithms. It's just kind of interesting that it has that as well. So it talks about like a thing. I don't know. But yeah, we can also just get this, but like I think it just things. So I think this will just do it. We don't need to go through the web archive. Secure hash standard. Nah, this isn't the document I wanted, I think. Oh no, this is the one I had been reading. Yeah, so these of course are not linked. But yeah, this kind of gives all the values of how it all goes. It is also kind of described in this wiki as well. Well, not described, it's kind of just given to you in pseudocode. So I potentially might just go off the pseudocode and build something that is similar to my SHA-1. So how I might get started is so if we go to source personal, and I think I can just like how do I want to do this? Yeah, I might just do this. So we can copy from. No, I do want to get in it a new SHA-2, and we can call it SHA-2 like that. And I guess this will do both. There's actually four algorithms in the SHA-2 standard. There's like they're just kind of different sizes, which kind of comes with different values. I just kind of want to see whether this had, yeah, this had just one. The SHA-1 just had one kind of thing, but it's still kind of used in some places. But yes, right. So um, potentially, I do want to just do like 256, but then like I can change the 224 and two. What? Lots of numbers. Don't roll your own crypto, they say. So yeah, maybe I'll do. This is SHA-256, and so in this, well, potentially I kind of just want to have like just SHA.h, and then that can kind of do whatever. But nah, we'll stick with just 256, and once we do the 256, the copying and pasting should be easy. So to start with, I'll actually copy and paste everything from the SHA-1 directory, including the .ignore file. Is that one? And then we can just update certain things. So this is SHA-256, and this is SHA-256 thing. So I guess where do we use SHA-1? I guess everywhere we do that, we can replace the. So how do we do this? We want to get everything, and everywhere we use SHA-1, we're going to replace with the same thing, 256. And that way the case will kind of also change. Except what happened there? Oh no, that's all right. Except we also want to do that globally. Cool, and then that can do that. This can kind of just go away. Right, RFC. What RFC did I decide it was? It was so we find the 3 and change this to 6, 2, 3, 4. 1, 3, and do the same. So the YouTube, I guess I'll have to to do, we can actually created the list for this. Well, I haven't, but it probably will be by the time it's done. Just want to get this whole thing out just to check what's going on. So what do I want to do? I think I want to swap sides. And so what this is going to do, and this is just going to kind of just print out the thing. And what is our expected output for hello SHA with a new line, we can replace this with so this selection we can replace with a command, and we can just run SHA. Well, we can run echo hello SHA-256, and the echo will put in the new line. I could do a print here, and that might be easier. And then we pipe that into SHA-256. Or except that, like, put it on a new line there, but that's kind of right. So we can do that. We can do that. And so that is the expected output that it will be. Cool. What else do we have? We also had get the we don't want that. Get ignore. We just do that. We did this here. Just I need to get my keyboard sorted. What else do I want to do? So we can do SHA-1 to SHA-256.h. And in here, I want to do the same sort of thing in doing 256 everywhere. And so here we're going to start with 100, I guess. The bit length is not right. So I'm just going to look up what it was. I believe it's 256 or SHA-256. And so this will kind of just do all the things, and like this potentially might just kind of work and do a thing, but there are things that might need changing. So what was one thing that could have thing? This had like max length that you could kind of change, I believe. Which wiki page did I see there on? This doesn't really say it, does it? Was it this page that I saw it on? No, that's maybe it was this one. I mean, I can kind of work it out from this thing, because we have to do shoot, okay. No, where do we put the link somewhere, don't we? Right, so L bits and L is a 64-bit integer. And what would it have been for SHA-1? What if we duplicate this and just go to SHA-1 is the one that I wanted. Um, so this is also a 64-bit integer. So I believe the well, potentially that open actually. But yeah, so that's that. And so what is the block size that I had with this? Like 512, but that's also 512. And is that just some math of 256 divided by 60 divided by 8 is 32. What am I trying to work out here? Where do we use block size? Block size is like the thing that we do. So it's the size of M. That's just different ways of doing it. Uh, well, I guess if that was 64, what was 64 times? Goodness. 64. I should just stick with the one keyboard. All right, so that was 512. Perfect. So there should be the bit size. Yeah, block size in bits is perfect. Um, right, so take me back to where I was. So what is this byte mask? Where do we use that? Right, I think. Do I want to kind of just look at the RFC? It might be. Where is the contents? Oh, of course. So we have Mrs. Padding. Um, all right. we have different functions. Here we can probably just kind of start doing that. And what if we have a look at what the first one was, just to kind of remind me of where things were, I guess. So when we look at the functions, so the thing that we were just doing was S. And we added. Oh yeah, circular left shift. So we potentially do actually kind of just want to keep that as is. Um, but I mean, this had a bunch of things. What was that? And that was just before shedding. Ugh. Operations on words. Yeah, so we can do all this and do that. And also do a shift right, which is just a normal shift right. And then we can do this rotate right, which we'll probably have to do a thing. And do we have? We don't really have that. So rotor, we can do that, and we can just say what it is. So that will be that way, and then or and then that way, and the W is always they say uh, that, but like we always have like a 32-bit word, yeah, as well, because it's the same bit size, right? Is that kind of what I'm thinking? But then in this we have different size, yeah. Then we have 64-bit words, so I wonder how I can kind of put a 32. Do we have any 32s? Um, nah, but we can kind of just have this. But note that it will be different for other things. That's just what it was, wasn't it? Yeah, cool. So we just need those two things. I feel like we also need these things. But then, like, when was this kind of defined? Right, so we do this and then we get all the W's and then we sort them all up. Then at step D, we should have some functions, right? We just kind of list them out manually. But I feel like we could probably make these a thing as well. Uh, like they just seem useful. Um, so we could do something like this, and then perhaps we can just copy that and paste that. And maybe go back to here and do that. Do that. And we can replace and with bitwise and everywhere. Did it not want to? And is just a thing that says that. And what else do we have? Zor, we probably want to say that. And not, we can actually get rid of the space as well, and we can replace that with not two like that. Two like that. And does that kind of look right? X and Y all are wrapped up, and then Zor, and then we have we have like a bunch of spaces that I don't really like there. One space I don't like. Right, so we can do that, and I think we can do that because we don't really need a thing around there. Oh, do we? No, because we've already got around the one, so I think that is sufficient, and then we do it again. Cool. What does Madge do? So we can probably do a similar thing and put it in that. How do we search for this? We can do something like this. And then do that. It's like kind of a gross thing. And then we can just search for something else. Search for something else. And then I want to do that. And that. That and that's just all we need, isn't it? And those spaces look sufficient. Cool. And if we want to kind of do these as well, maybe. Um, so what do we have here? We have what's this to kind of mean? Um, in was just a count with it. Yeah, easy. We've already got that. The code is in a slightly different thing. So what's this? B sig 0, and it just takes 1x. What do we do? So this is going to be a SHA-256 rotor, and we're going to have 2 and x. XOR SHA-256 rotor 13 and x. And then we XOR that again and SHA-256 rotor, and here we have 2 and x. Right, and here we can that, do that, and do that, and then do that, and then 25. Do something like that, and now we can. This is S sig 0. Gosh, they make their names, don't they? So we can just do that. This is a nice little thing. Maybe I want to play that. I think I've got some music for that, maybe. I recognize the name for it. You can't hear the music, of course, though, because like copyright and whatnot, and it's just easier to do it. But I find sometimes it helps me go a little bit. Now you're just going to have to wonder what I'm listening to. So shift right 3. So is that just that that shift right is of course it's that away, and then that all gets done like that. Cool. 256. Can make sure that you're on the same thing. Otherwise, I can't even see that. Um, Otherwise, you implement something that's not right, and then it won't work. Um, how they come up with these numbers, don't know. Feels like they just pull them out of there. You don't know, then I don't know how I can help. Do something like that. Cool. Right. Um, right. So I think I kind of want to do something like this. So we can start with the padding one. That, I believe was right. Maybe I do want to kind of keep that, but anyhow, we and what are these? These are the message padding. Excellent. So we can just maybe it's best to go to the bottom and kind of see what's kind of happening here. Um, so um, defined in RFC 6234 4.1 because it's SHA-256. Cool. So what was it doing for this? So number of bits more for that. Basically, we get that. Yeah, it says the length there is the max length. So one is appended, then a bunch of zeros. We're doing byte-wise, so it will just be like a HO in the hex. Then a whole bunch of zeros until we can write the entire word at the end, which is a two-word representation. Right, so this kind of says it a bit better, but it's very verbose. Oh, we could potentially change this to make it look a bit better. Yeah, I think I kind of want to spell this out a bit more. So we can make an assertion that the length is less than the max length. And it has to be that, which makes me wonder if I should kind of update SHA-1. Yeah, that's should be something like that. Which like it's like kind of enough. Like I don't know. I have a little thing. So this is not really adding a feature, so I think that kind of patch level is sufficient. And so we can add that and what we call it, 2. Version 2.3.1. And what do we do with this? With edge case of max length. It potentially could have caused an issue, but like you would have had to have a massive sized thing, or oh, that's not what I wanted. No, I wanted that one. Cool. And then I probably just want to get out of there again. Right, so getting back to this, we have this. I don't know why I'm typing this out again. Um, maybe I'll make a comment. No, as we rating bytes wise, the 080 for A dot and 7 bits of K. So I think I want to I mean, like, what is this doing with link and whatnot and IDX? So IDX is going to be length but kind of fit into the block size. So it's going to be the length of the index into the current block. And then we, for some reason, linked multiplied by 8. So I guess that's how many bits we have. And then we add on an extra 80. And if that kind of puts us over the edge, like if we can't write the if we can't write it, then we process it, and then we kind of continue adding zeros from the start of the next block. So we reset it, then we start the next block, then we zeros added all the way up until we're less than 0. And so this IDX is kind of the equation L plus 1 plus K. So I'm kind of happy to kind of keep this. And if we add 8 to this, we don't get. Though if we do that 8 more times, 7 more times, 6. 1, 2, 3, 4, 5, 6. That's like heaps. So what do we have? 5, 1, 2 minus 4, 4, 8. And so that's 64. And so that is the length of the length, which should be 8 bytes precisely. So yeah, this kind of does this there as well. I feel like this is kind of just doing the right thing. Um, so that does that. And then so I think we will do that length there. It doesn't really mention about the overlapping, but it is just kind of what could potentially happen, and this is kind of still enough for that. Cool. And that's for the higher bits. These are the constants used. Right, so we have a bunch of constants that we should probably make. Right, so um, this is 6234, 6.1. And the name was just H. So this has two more, and kind of how best to do this. None of these are right, so may as well kind of get rid of them all. I kind of want to copy that entire text, and that was just a race condition with myself. So at this point here, I want to do some things. So we can just go there and just do that. So that is that. Um, True. Well, well, indeed. It uses such different terminology from the first one, which kind of just is like this. This is how you do it. So we had a sequence of 80 words in there. Um, so these are the 8 working variables. Oh no, that's the hash value. The H. But we do have some working variables at some point. That must have been in this. Yeah, so this is the chunk of the thing. So yeah, so here we do this, and we pad it according to that, then passed into 512-bit blocks, and that's 16 32-bit words into M. So where is my M? That's just block. And so if we hit a block edge, we process that just as we get to it. And then we do for each of the blocks, we do this. Easy. So in process block, we have SHA-256 uh, block processing of this defined in C 6234 section 6.2. 6234. All right, so we have working schedule, and this is not 80. This is 64. 64 there. H is 7 word buffer. And FG, I guess. I don't know if this is what they call it, but I'll just kind of change that all there. Lucky we didn't get up to 8. Right, so here we don't have step A, we have what is happening with this chair. It's got the wheel at the front there. Yeah, there we go. Right, so this is actually step 1. So T is 0 to 15 now. WT is it's just equal to MIT. So what is this MIT? Where did it define that? Oh, is that just message? Message index. Yeah, we even have the M up here. So this is just going to be right, so this is just the M, the I is just part of this. Oh yeah, because we're doing this for every block. And so we'll just get whatever M we have currently. So I think I can kind of just ignore I. And did this have like, what did this have? Oh yeah, so this is kind of doing the same thing. Because we need to kind of get all of the words up, and so I guess that means byte mask I just kind of head out of there. Right, so from 16 to 63 was it? We have, this is now going to be SSIG, the 1 version, and golly, it was going to take in W of T minus 2. did we need just up there? Yeah, we just needed one value. Easy. Right, so it's just going to be that plus W of E minus 7 plus SHA-256 sig 0 this time. Interestingly, there's a lowercase w there, but I think that's just a typo. Seems kind of odd to have typos in the aspects of this, but right, so that can be that. All right, so this is actually step 2. Do I kind of want to maybe make some comments and then initialize the working variables? Oh, this is good. Um, so went up to H. I mean, it's definitely confusing. So they just have lowercase for all of them. That kind of suits me. I'll do something like this, and then do that, and then that easy, and it will just be kind of happy doing that. And we can do that, and this can go to H, and our H just variables, I think they call them. Working what is cool? Yeah, that's that. All right, so down to working variables. Right, so I think we can potentially do something like yoink and do that and do that and do that. And so what's this I minus 1 business? It just means whatever is in there at the moment, because at the moment it's got oh, bit of a sting. Oh yeah, you didn't want to do that, sorry. Right, so in this it just kind of means what it currently has. So we can just do that. Now these K's we had kind of already defined somewhere else. So the K's here. So there should be 64 of these things. Golly, they're just all there. Maybe I want this to be more like that. No, how do we do this? Do something like that. So I want this to. Oh yeah, we can just do that. Cool. Except I kind of wanted to do maybe something like 0x and then to the end and then do that. Yeah. And then here we could, I think, just do like 63 more of them. Nah, so we can't do that. But we could make. Do that. Yeah, cool. I think that kind of works. So now we can do a QW, and we can do 4 of the Qs, then delete that, then quit. And then now we can do there's what 12 more lines of W. I didn't like it. Oh, it's because that kind of just stops working. It kind of kills it. So I think I want Q needs to be better. Um, cool. And we don't want one on the end. And like this is reasonably unruly. And now that I've done it, I do wonder if I want to. These could surely be defined somewhere else. Are these just always going to be constant? Yeah, so these are just always constant. Did that a little slow. And just do that, and then do that, do that. Define RFC. What RFC are we doing? 6234, but section 1. Right, so in these, I think I do want to do like. Can I do that? Yeah, I can do stuff like that. Cool. So what if I do that like that? No. What if I do that? So how many did I get there? 3, 4, 5, 6, 7. Does that kind of divide nicely? Nah, it doesn't really. So I think I do want it to be kind of more like that. that one. And then like, what arrangement do they have? They had groups of four. So there will be three. No, that would be four join. So we do four join, then down, then quit, then that's like, 2 lines of that. Cool. That can just be okay. That doesn't take up that much space, I guess. Back down to, gosh, down here. Yeah, so perform main cache computation. Um, what is what is nice. Cool. So this can just be that. And what are we doing for this? So we have another one. Zero t is less than 63. T plus plus, and yeah. So I guess in this one um we had it like plussing f, which had like different values for different t ranges, but this kind of seems like everything is it's either in this or it's one of these functions here which don't depend on t, which yeah, I think that's kind of a makes it nicer to kind of implement. So in this, what do we have? We have T1. Do we actually have um, how do we get out of this mode there? Do we have a T1? We don't really say that temporary words. Yeah, so we do have this. So we call them T1 and T2. Um, Easy. So T1, maybe bring that up there. T1 equals H plus SHA-256 B is sync, and the first version. And uh, what is E? E is just one of our local things. And then we have SHA-256 SHA, and then we E, F, and G. And then we have K of T, and then we have W of T. So cool. That all should be there. And then T2 equals SHA-256 BC 0. And this one's A, and then SHA-256 mange of A and B, C. Then H equals G, G equals F, F equals E, E equals D plus T1, E equals C, C equals B, B equals A equals T1 plus T2. Oh, and so like these things get yoinked, and so this is now just the last step. And of course, this is so we're plus equaling because I minus one is kind of just what it was before, and so now we can just go well, like almost just do this. And that was, can we, no, we can't, but we could do, why isn't that working? Where's my key? Do something like that, but all of these are that, just, yeah, cool. So I think that's that. So, and we did the padding block. I wonder if this padding should kind of come earlier in the document because it's kind of, this is 6.2, but then this is 5.1, and like the padding was 4.1. I don't know, I think I'll just leave this as is. And we changed these to, yeah. Right, so after the computations has all been performed, the final output is just the concatenation of all of these. So I represented, well, like, can we just kind of copy that? Yeah, I think this is good, but without that, maybe, yeah. Maybe just with that. And so here we can find 5 and do that to 7 instead. 8, sorry. And is this kind of what I want to do? Yeah, so like H. I think that'll probably do what I want. Cool. So what if we hit the end of the file, 240 lines. Haven't done this stuff, or this stuff, or this stuff, but I don't know. I reckon I'll give it a whirl. So we can open up example.c, and this had like that example.c is not what I was expecting, because I kind of want this to have the example from README. And can we do something like that? SHA-256, look at that. And because of that, I could potentially make the README kind of do that, and so that would be SHA-256 here, and we just do that. It just does that same thing, but yeah. So what if we do a little compile of this? I don't want that. I just want GCC. Cool. So that had some issues. So what I might do is set make brg equals GCC example.c, and then we can just do this, and so we don't have this. Do we want to include a cert in here? I guess we could include search.h. I think it is literally the only place I've kind of done it. Because the rest kind of makes sense. I guess after pad block, we could make the assertion that I don't know. Right, so excess elements, we did actually have 8. That's all right. Cool, that works. So now what we do is we go into personal and go into SHA-256 and run a.out, and we get a thing. So it doesn't crash. And then we look at our README and we see it's a different number. It's different. So and that should just have the same things with a little new line. So I could do the same thing. Do that. And what if we pipe this to SHA-256? It's that 3B. That's kind of what I would have expected. So I guess something didn't work. And there are like test vectors I could kind of grab up from them. Are they in this test driver? Because there are like a bunch of tests that's like not the nicest place to do it, but yeah. There's a different file that I've seen with like all the test vectors and like it kind of showing where they are at a point in time. Do they kind of show it in here? It's just the same. That is just the same. Cool. Well, if that is the case, what I might do is like maybe just do another cheeky check of things. I didn't change this, did I? No, 256 is still 256. That's what the name is. I was thinking 512. Uh, that's just. Um, the painting did all that, and X and Y. Your not X. Yeah, yeah. I mean, I just copy and pasted. Two, 13, 22, 6, 11, 25, 7, 18. Right, 3, 17, 19, and right 10. Seems legit, and that looks like I copy pasted it in. I did do like a bunch of kind of stuffing around with it, but I mean, it looks pretty good. Just looking at a couple of random ones. So I don't think I kind of changed that about. Right, so we also had some initial values here. This doesn't look right. Where did I get? This is 224. That 256 is these values here, and that looks legit. And so for every message, for every block, pretty much, making sure that we had it. So we know the whole size of the message, which is just length, which is the length of the data pointing to there. So based on that, we can go through and kind of add stuff to it. If we ever kind of spill it over a block, then we process that block. Otherwise, we pad it, which will pad it to that length, into just our block object, and then we'll process it again. This seems legit, so we append that, yeah, and then we kind of might need to redo a message. And then we that was kind of like separate. So that's like while we're not there, then we kind of need to get down here. Easy. Looks about right. The next little place I needed to look at was yeah. So for everything, we're kind of and M is just the block that's kind of passed in. So this is and is this right? Um, uh, I don't know. I don't know. Or do we have to process it after we pad it? We do down here. Yeah, so we pad it, then we process it again. I don't know. I might have to kind of think on this and kind of come back because I don't know. It's maybe I naively thought it'll just work first try, but I've done the SHA-1 before, and I do recall running into issues there. Well, I guess I haven't fully finished checking all the things that I was going to do. So this is kind of just turning it into like so what's it doing? When we're adding to the block, and it's just going to be whatever the data is. So at the end of this, we should have whatever the data is. Makes sense. We want to hash data. And then here we are getting 4 bytes, but we're kind of swapping the order. Is that kind of what I'm seeing there? It's kind of assuming that I'm on an Intel system. So Intel has low endian, and I want it to be in big endian, which is why I'm doing like a kind of weird shift about, but it does make an assumption there. And it kind of describes how it was kind of smudged up into uh, yeah, like integer word and whatnot. Big Indian convention. So that is what is what. What about the rest of this? So sig 1, and then WT minus 2, then T minus 7, and it's outside of these brackets, and then plus sig 0, and then W. This like lowercase w is kind of a bit weird. I noted it before, but yeah. I think it's just a like weird typo. And then T minus 16, and that is, I set that. I think I need equals, yeah. I think I need yeah, so this one, similar loop, but it was going all the way up to 16 because we want to go 0 to 15. So almost maybe do something like that. And then same thing here is up to. And so I think if I go make, yeah, that does that. And if we do that, we get a different thing, but I think it is still not what the expected is. Oh, yeah, the expected is that one. So, yeah, made a change. Just did something different. So where was I at with that? So that would probably also need one here. The, come on, let me do what I want to do. Cool. Yeah, and that does it. Easy. You just got to remember how far up the arrays that you want to go. So I don't know. I could do more testing, but I am quite happy with the outcome of that. So what I might do is kind of shove it up on the lines. So I think we need to go to GitHub, and then we can go repos, and maybe I can just copy paste that, and we can call it SHA-256.h, and then down here and call that 256. Don't add anything, please. And where's the button? It's behind things. All right, and then we just need to that come up there. Should do me the trick. We need to kind of add everything up that we did. So initial version 1.0.0. And just do that again. Remote already works, that's all right. But now we are pushing, and cool. So that should be that. Easy. Well, I guess thank you very much for people watching this video. I made it in the end, got it working, and yeah, it might be some interesting things in the future now that I have SHA-256. But yeah, keep watching, I guess. And yeah, until next time, I'll see you and have a good day.